I really like this regular expression matching question. I answered it many, many years ago, and I kind of wanted to go back through it from scratch just to showcase how I might go through it. I don't prep these questions ahead of time, which is unfortunate for me, but I think it's useful for you. I don't like coding in this IDE either, so I might copy back into this in the future, but might not even do that. Perfect. So now we have an easy way to add tests. We just add a line to a row, and we need to make isMatch. And let's get rid of this cheating function. The way I like to think of regex is you have a linear scan over the rules, and you're effectively trying to verify that that linear scan actually satisfies the rules. So obviously dot and asterisk are important, and for now we can just work on not dot and asterisk. So we're gonna have a function for def char handle char, and in handle char we're going to take a substring and a char, and we're effectively going to return sub 0 equals char, and maybe we'll handle the base case if sub and then we can actually do this even better, I believe, by just doing an and if sub. We can do len sub, but and or if len sub is positive, that'll be true, so then it'll go to another one. If not, it'll be the other one. So then this is a nice little function. I'm going to pull this out just because it makes it easier to test. We could technically make an object and handle that better. So now we're just going to make sure handle char works well. Handle char, and then here it's not as hard of a question, so we just want to make sure that assert handle char and then just a positive case. So handle char, in this case we'll say AA, and then A, and then assert not, and then RB. Okay, making progress. Regex. I don't know. Oh, def isMatch. Pass. All right, cool. So here we have regex. We're checking isMatch, and isMatch is failing on 3 tests, but it's passing now on the other one. Perfect. So we have this idea of handle char. So now we want to handle dot char. So handle asterisk. Repeater. Yeah, we'll say handle repeater. It's not exactly the same. So handle repeater here can do a few things. Handle repeater, it doesn't just return a match. It returns 3 possible things, because we can have asterisk A and then have here, let's make a new test case, asterisk A and then AA. So handle repeater is a split. It's a split of multiple ways. So I think handle repeater is a split that says we're going to have the option of continuing without the repeater. So we're going to have options here, and options to start is going to say sub, and if we don't handle it, we can't handle it in the future. So then we're going to say okay, so we'll say we'll have options, and maybe a name tuple would be better here. From collections, import name tuple. Honestly, I always have to from collections import name tuple, and then help name tuple, and then here we have cool until xy. Cool. Oh, that's pretty straightforward. All right, so we're gonna exit here, and we're basically gonna say, what is the return of an asterisk? So the return of an asterisk is a repeater fork. And a repeater fork effectively is a name tuple where it's a repeater fork. And sorry, just want to double check, make sure I remembered that correctly. Yeah, and then the list of strings. Cool. Honestly, it's a little silly, but I think for now we'll do this. All right, so here we're gonna have the rest, and rest. Okay, we're gonna have an all, which is like the whole string, as if the repeater was not done, and then we're gonna have a rest, and then we're gonna have a pattern. And this basically lets us say that we're gonna have a all rest. Okay, so if we apply the pattern, so if we don't apply the pattern, we know what all is, so we don't have to do anything really for that. If we apply the pattern, there is a rest, so we're going to apply it as if it were a char. Okay, and then if char is dot, we're going to add support for dot here. So let's make this dot here, where we're gonna have dot dot. I don't know if that works. That looks a little menacing. We're gonna do that. All right, so if char is dot, and we need to make sure that n sub 0 is not equal dot. No, dot, it actually works for that. It's just only asterisks. Actually, it doesn't matter about that. Yeah, we're if is a dot. Okay, so then the sub 0 is char, I guess, or char equals dot. We can actually do this. This just handles the dot case. We're gonna kind of a little bit all over the place, but I think this is a nice setup. I need to fix that. And we're gonna run. One failed, cert, none, false. Okay. So then here in regex is match. For now, is match is just handle char SP0 for now. We're gonna like kind of handle more things, but for now we're just gonna do that. Is a match dot one pass, which test pass, true, false, 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 assertion error, test regex, egg, dot, assertion error, fim regex, okay. Is match SP, SP dot sub 0 equals char, or char equals dot. think this is a reasonable setup. What's char here? Char is dot here. All right, so it seems like we're getting an issue, so I'm just going to import PDB here. PDB.set trace. Actually, we're going to assume right now that for char in P, we're going to assume for now that it is, and we're just going to be like is valid equals true, is valid equals is valid, and handle char s I to end of p of char. We're just gonna like increment it, and then we're just gonna return is valid for now. I like doing these little incremental steps. So for, and then here we're just gonna, for char in p, we're gonna check, I guess we need an I here, char in enumerate p, and we have the I there, is valid. Okay, this seems like it might be closer to what we want. All right, 2 fail, 4 pass, cool. So we're able to scan. We're handling dot. So we're failing on AAA, which is incorrect, and we're failing on A dot. A dot. So let's make sure A dot is correct. I feel like A dot is fine. Yeah. So that test passes. We're just not handling it right. Is met A dot. If char equals dot, import PDB, PDB.set trace. I use this format. You're gonna see me do it in almost every single time I share anything because it's just my way of making sure that my system won't accept the PR. Sub 0 char true, and this should be true. No, I said that something's off there. We'll leave this here and then test A dot, and then we'll just do a isolated test of this. let's see if that test passes. A dot assert true equals false. So it's saying true, but is a match is false. Is that right? Huh. I think this is just where we're actually not. Okay, so I guess it's not to spec. So then in here we're gonna have to give false, true, 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 true. And then here we're just gonna say regex is valid. Yeah, I guess we're not to spec. It's fine. I don't know if that's accurate, but okay, cool. So we're missing the asterisks and the double A. Interesting. Oh, are we not incrementing? Okay, cool. So we might have actually, I mean, it's fine. Okay, I believe this is true. Okay, cool. So we're able to scan, and now we just need to figure out how to handle the repeater. So in this case, we have an asterisk, and an asterisk has to be followed by something. A asterisk, right? According to this setup, we have A asterisk, so it means 0 or more of the preceding element. So we already know that we need to get the previous element. So if we get an asterisk, we need to get, we have a char as well. Okay, for char, prev char. So then in this case, if char equals, and like we're gonna add the error case. We're just gonna handle the positive case here. So if char equals asterisk, and we'll just assume prev char and prev char is not none. Now we're going to handle this. So in this case, now we have to answer the question of, is that a match, or like, are any of these matches? And I think that's actually a reasonable setup. So we can say handle repeater, and we know for handle repeater we need to give it SI for that situation, and then we need to give it prev char, and that's what a repeater needs to then give us a repeater. And in a repeater we need to effectively say, is it this without the repeater? So the repeater needs to receive is valid equals is valid or and then in this case it's is match is match S I plus 1 and then actually no, we can do is match repeater dot all comma p. We don't know where we are in p. Range len p. Actually, I'll just enumerate. And then for here we have repeater dot all is match repeater dot all with so in this case we need to get the pattern. So we have P, so it's PJ plus 1 to the end. Or, and I guess in this case we would be returning. Okay, so is valid fork if is valid fork return true. So in this case we're going to return is valid if it's already valid and I can match the rest without using it, or I can is match repeater dot rest with repeater dot with we're assuming the repeater's still there, so we just need prev char here. Okay, let me see if that's correct. So it's either we use the repeater, so we don't use the repeater, but we don't have it anymore, or we use the repeater and we have it still, which means we would need the rest of the string, and we would need to tell the repeater what the previous char was, because we're still repeating on that. Okay, and then if is a valid fork and it's valid before the fork, then we return. Otherwise, we can ignore that repeater match and continue on as if we're done with it. Else, if prev char is none, we return false. This is basically like no char for repeater, which is just invalid syntax to begin with. And then otherwise, prev char equals char. And we just kind of update the previous char. There's gonna be some boundary conditions, which we can check. So here, if I do Python, we might have 1, 2, 3, and then we might say 3. Okay, cool. So it handles it reasonably. Regex. And then if it's empty, what is the answer? So if it's empty, and there's still chars, all right, handle repeater. So here we basically are going to return a repeater fork, and with this repeater fork, we're going to give it sum. So equals sum, rest equals sub 1 this, which will just be 0. But we can't do that if we don't handle it. Okay. I don't think the repeater even needs to know about it. It's just like the compiler. So if we handle else, return okay. So that means this let's just get it. Okay. Let's turn this off. I haven't ran any code in so long. This is like the worst, but this is how my brain works. All right, and let's see. It's probably not gonna run, but all right, cool. Assertion, false, false. Okay, where false equals equals. All right, now we're gonna start combing through here. It's exactly how you're not supposed to do an interview, but I'm not doing an interview. I am just enjoying to code. Okay, where do I want to start? Okay, let's see. So here, I want to know import PDB. PDB does set trace. I want to know if I'm here. I want to know if I'm there. And I guess else. And then here we're gonna print. We don't need to print. So it's either it's an asterisk and I have a pre-char. I messed up somehow the string and I just return false, or it's a character, which I have to update the previous char. And handle char, some char, some rest of one here. Okay, I guess in this case, rest is empty. Return all sub rest sub handle rest is empty. Yeah, okay, this looks promising. And then in here in the is match is valid. Is match repeater. I think I'm gonna have trouble with the empty case, so that's probably just like a base case I need to have. All right, so is valid s I. Oh, it doesn't like that. S. I see. Let's get rid of this s nonsense. Okay, sub pat char sub pat char. Okay, free char. Ooh, interesting. I'm running into an issue of asterisk being handled incorrectly because asterisk is not being checked for in the setup. So what we need to do is we need to make a preprocessor for tokenize pat. Okay, cool. So the tokenize, which we could have named this better, but we have a pattern. And then for the pattern, we basically just care about handling asterisks properly. So then in this case, we basically need to find all the asterisks and then cut it out of where it is now. So then in that case, a lot of our logic will change a bit, but we can just basically we can iterate through. Okay, so I guess we have an index 0, so we're not going to iterate it like actually we can just iterate through I plus 1. Okay, yeah. For I in range pattern, and then we'll say len pattern, and we'll just minus 1. So we can just assume that the current pattern is like char equals pattern I, and char 2 equals pattern I plus 1. Okay. If we don't want to double count, so and O equals this, and then now we're just gonna say if char 2 equals asterisk, then we need to out.append, and then here we're gonna say char plus char 2. It's not the right way to do it. It's probably a function we can do. Given the difference in the way that they're handled, I don't think right now I have the best options, so I'm just going to do that. And then here we need to do I. We don't want this, so while I is less than pattern minus 1, and then I equals 0. We're not really going linearly. I plus equals 2. And this is just saying, like, we have this new char, which honestly, it looks like it would be an object that kind of handles the permutations. So maybe handle char is going to respond with a yeah, okay. So handle char would just respond with rest. So this is just a fork, repeater fork, and this is just a possible fork, and the repeater is now a possible fork. Okay, so it's just a possible fork, right? If it's an all, then it is a stay in the current spot split, and if it's a handle, then it is a if len sum and this, and then here it has an is valid. Yeah, I think this is going to be an interesting reformulation. So if char equals dot, we don't actually need this anymore. If len sum and sum char or char equals dot, then return possible fork. So now we're just trying to like join our subclasses. I don't even know how long this is, an hour. So possible fork, and then in this case rest is going to equal sub 1 to the end, and then is valid equals true. Else return valid is false. I don't know if all of these require it to be set. So then here, possible fork also, and then here always is valid equals true. Is valid equals true. And then here, and repeater. This is always true, so we don't have to worry about the handle repeater. And then here, handle char dot is valid. I don't know if this will work. There's a lot of copying here, so I suspect I can do this a little bit better, but for now, like maybe for handle char, we don't need to give res. We can just respond with is valid, because it's a special type. And then that copies a little less. For handle repeater. Wait. In which case here. This tokenize is something we can test. So tokenize. Okay, that's organized. Zero equals a. Okay, well, I is less than pattern. Test organized index server. So it's a string of length 1. String of length 1. that test. So here, and then len pattern. Yeah, it's 0. We can't do that. So let me see. So if it's a string left 1, we can just handle that. It goes out if len pattern greater than 1, else. Okay, and that solves our. Okay, cool. And then here. Okay, so we're having some off by 1 bug. So here, if out, and then I is not the last character, so if so I is for the last character, so if I equal out dot extend pattern that just gets the leftovers. Should be good. A. Cool. It's just some corner case handling. So basically we have an empty list, or we have the first number. This is just so we can increment by 2 without breaking things. We check char 1, char 2, char plus 1. If we find an asterisk, we need to increment by 2, and we need to add this double char to the system. This is just to not handle them as like a special function, although we could have. And then otherwise we add the char, we increment, and then because we're only incrementing by 2, if we end up with like 2 elements at the end, we're fine. If we end up with 1, there could be a missing value, right? We don't want to double check here. So then we just add whatever missing values we had, and then we added the beginnings. And then to not add a missing value to something that we found, we just say len out so that we know we're like at the end already. Okay, cool. So we did our tokenize. And now let's run our PyTest. This is probably not going to pass, but it's going to get closer in terms of the logic's getting close. Lambda missing 2 required position. Interesting. Yeah, I thought that might be the case. So then here, I think we need 2 different objects. Okay. We don't really need 2 different objects. I think we could have. I'm just going to go back to the repeater fork. So we either handle repeater, let's just add a break for this. Okay, so I don't have to worry about that here anymore. Which is good. So it's either a 2 or it's a single. And if it's a single, we just need to worry about char is token. Okay. So here we have prev char equals token zeros. And then so prev char plus. Yeah, little changes we did here and there. So we have sub I. So let's isolate one test. Possible fork is not defined. And repeater fork for the win. Oh, cool. We're done. That's kind of how it goes for me. I usually, almost an hour. Okay, that's pretty good. I don't know if I probably would have been given more. I don't talk too much during these, so sorry about that. But that's basically how it goes. So this is a hard question. I think there's a few things we can do to make this a little less tricky. But yeah, this is an is match, and then we can do a more complicated example. Let's see. So here we can have something like A, B, B, C, D, E, and A asterisk, B, B, and then D asterisk, C, E asterisk, D dot asterisk. That's a pretty interesting one. Rest. Okay. Okay. Rest. In this case, if we didn't handle the subchar, is that valid? So empty rest seems a little weird. Okay, so then okay, yeah, we'll just set rest to none, which is our current assumption. Cool. So let's see, first off, is this accurate? A asterisk, AA, BB, okay. D asterisk should be ignored. C. Ooh, E asterisk there is bad. Oh, yeah. Actually, I think it should be good. So it's AA, BB. Okay. D asterisk is ignored. We have C. Okay, then we have E asterisk. And then we have dot asterisk. Okay, so it should work. But it's not. So let's see. So here, let's see. I don't know how to run parameterize just for that test. So what I'm going to do is I'm going to copy this guy, D10D, D11D, and then here test, we're just going to ignore these guys, and then we're going to call this test current, and then we're going to pytest regex -k test current, make sure that is working. Perfect. So now we're going to work on this problem. And I think the most interesting place to be is right here. PDB, PDB dot set trace, and I think it's in this OR. Actually, I think it's in this OR that, like, yeah, that we're gonna have the issue, but we'll see. All right, so let's start debugging this. So here we have char 2 equals asterisk and char equals a. So then here char 2 sub okay, cool. Pattern I. So we're at this BB point, which I think we find with. Okay, so pattern I. Okay, so we're at this BB point, which I think we get past pattern I. Okay. Okay, this is where I think we start messing up. So here we should be in this. Ooh, okay, char 2. Okay, cool. So this is just generating the tokenize. Let's get out of tokenize. I see. So this is in tokenize. So I think we're fine on tokenize, and we want to figure out here where we are. So let's see. So here we are. So we got prechar, and then is valid. If it's valid, ooh, token should not equal that. Why is token asterisk? Token is correct, but that means maybe my is match tokenize. Oh shoot. I see. So rest here. Okay, so is match recursively. I see. It's calling rest on the elements. So like with recursion, you kind of have to do this. It's just a way to make it so that you can do recursion without having to have the same inputs. So in this case, handle repeater, it doesn't take a sub. So handle char just takes a char 1 sub. Yeah. So this is just like a new setup. So here, and then handle repeater takes I think handle repeater actually should just take a token. And then it should return so yeah, I think this whole thing seems like it's actually unnecessarily difficult. So we're gonna get rid of this handle repeater. So handle repeater is actually like not really that important anymore, I think, because of this new token setup. So then here, we basically just want to do handle char for your token. Okay, so we know this is is valid char equals handle char for your char. Sub I. Right, so is it a valid char? And if it's a valid char, then we basically have two options. If it's a valid char, we can either do the res. If it's not a valid char, if it is a valid char, then there's a rest basically. And if there isn't, then there's just an off. And then we return. So we're going to do that once. it's valid char, is valid, is valid, all, is match helper, the rest of the tokens, and then the rest of that. Is valid for then there's an or. This is the all case. This is actually the current case. This is just, I don't care about anything. And then if is valid char, then we also get the case of is match helper. But in this case, we're saying it's I plus 1 in tokens, including this current token. So like, and then if is valid repeater, return true. Is on fork equals, okay, cool. Yeah, so I think that solved this case. So we have, and then is valid. It's funny, we have like a kind of like a quasi recursive, non-recursive implementation. We have like a linear scan with a recursive. This is like a quasi. I wonder if it works. Yeah, it is not much trying to see. Let's fix little bugs. Is on repeaters. Yeah, I think this is close. Okay, we might have an infinite loop here. Okay. Okay. For j, comma, token in enumerate I equals 0. If token equals 2, preview char equals 0 is valid char, preview char sub I. Is valid repeaters. Sub tokens j plus 1. So in this case, assuming I'm done with this. If I'm valid. Keep going. All right, so let's start to see. At each run, we're going to print sub token. And I. And J. I don't know why J is there. Oh, I see. So if I is greater than len sub break. It's like a little chaotic. So he has sub a token a asterisk 0 0. I actually am almost positive I probably broke some of this stuff. Yeah. So let's see if we can make this a little simpler. Okay. Kind of think a recursive solution is starting to come around. So in this case, I don't think I need I. So I think the recursive solution is like slowly, basically. We just need to take the current one. So in this case, we effectively have if len sub equals 0, and set len token for token and tokens equals set to return true. Okay, so everything's asterisk tokens and we're at a 0 string, just return. If lens we don't even need to know. If len 0, yeah, this is an expensive call. I don't know if I want to do that right now. Okay, so if it's 0, what do we need to know? Okay, it's an and, so it's not going to do the expensive call unless we reach 0. Okay, so then if len 0, then we just return else. We know it's length greater than 0. So then in that case, we want to handle the first char. And we can just call handle char sub 0. tokens 0. If len tokens equals 0. Okay, cool. And then here we have tokens rest equals tokens. And we have in this case we know okay, so we have sub rest, tokens rest. Okay, in this case we know we have a token, so we can handle char. Token 0. If there's an asterisk, it doesn't matter. Okay. If is valid, we have effectively two options. If len token 0 equals 2, now we know we have both the handler case and the other case. And we're positive until this point because we haven't broken out. So we can return is match helper of sub tokens 1 or okay, we don't need a return yet. Is valid fork equals actually we know at this point regardless of is valid. If tokens it's an asterisk token is valid fork equals is match helper. If is valid, that means there's a match. Is valid fork equals is valid fork or is match helper. And in this case, it's of sub res tokens, the full tokens. Okay. Return is valid fork. If tokens else return is match helper of sub rest tokens rest. Just deleting it all. That's crazy, but let's see. So now the nice part is we're just going to print out this input. that is our sub. We have A star, B, B, D star, C, E star, dot, asterisk, and we have that string. So we got rid of an A. Now we try to do it. We got rid of two A's. And now we skipped over to D. I see. Something's up with the A star. Should have gotten rid of both A's. Okay. If len tokens. Okay, if len tokens equals 0. Yeah, if you have no tokens, then you have to assume. Okay. If len. Okay, sub. Okay, so you have empty sub or not. And then if there's an empty sub, then okay. Let me see. If len tokens not equals 0. So if we have else, I guess it's like return false, right? Okay. So if we have tokens rest equals tokens 1 to that is valid. Handle char sub 0 tokens 0. If len tokens 0 equals 2, so this is a asterisk is valid fork equals is match helper the sub with the rest of the tokens. Let's use rest here, tokens rest. And then if is valid, so that means the char matched, then is valid fork equals is valid fork, okay, or is match helper sub rest. So this is matched and we want to do sub rest tokens. Return is a valid fork. Okay. And then sub rest sub. So this is sub tokens rest. So then else, so this is so single. And we ripped off that token from the beginning. I mean, it looks promising. So here A star B. tokens is long. So that here tokens rest tokens. One of these cases wrong. So I think I just need to start printing out here. There's like a lot of if statements. Let me see. So if len equals 0, return this. Is valid equals handle char. So else we have no tokens, but we have this, which means they're unmatched. True, return false. This looks better. My boundary case is wrong. Is that an or? There's an or. So we did the first round, A star. Okay, we ran it. And then we took out an A and we ran it with everything. We took out another A, we ran it with everything. We're like, oh, I can't use it. We took out the A star. We ran the B. Okay, B removed. Okay. So now we have D star and CED, which we removed D star. E star matched the E. Cool. And then E star tried. No. D dot asterisk. It ended up with the D empty. Okay. Somewhere in here, handle char stopped working. Or PyU stopped. I think we got it. Okay, so now we have that. Okay, this looks good.